Hi, my name's Alan Smith. I work at Active Solution in Stockholm, Sweden. And in this session, called Graph of Thrones, I'm going to be exploring the graph database capabilities of Cosmos DB using the Game of Thrones as an example. A bit about myself. I describe myself as a developer, trainer, mentor and evangelist. I'm also an Azure MVP and I do a lot of work with the community. I have a YouTube channel at Cloudcasts. I also speak at conferences and organise conferences. So I've been involved in organising the Cloud Burst and the AI Burst conferences, which are free community conferences which we're hosting in Stockholm, Sweden. So a bit about Cosmos DB. I've been working with Cosmos DB for a number of years, using it in a few customer projects and also experimenting with Cosmos DB myself. As you know from looking at the other sessions in this conference, Cosmos DB provides us with a global distribution. We've got a fantastic elastic scale out, so our databases can scale very dynamically based on the load we place on them. We've got guarantees on low latency, and we've also got these 5 well-defined consistency models and comprehensive service level agreements covering the availability and the latency of Cosmos DB. So this is a diagram showing the 4 database models that we've got: the key value, column, family, documents and graph, and also the various APIs that we can use to connect to Cosmos DB. And in this demo, I'm going to be exploring the graph database model, and I'm going to be exploring using the Gremlin API. And these two work together. If we're using the graph model, we'll be using the Gremlin API to be able to access that. So a bit about the architecture. If you've worked with Cosmos DB using the document model, you may be creating databases, and then within those databases you generate collections and you can create your documents within those collections. If we create a Cosmos DB account using the graph model, what we're going to be doing is having databases, and within those databases we're going to be creating graphs. And you can generate multiple databases in a Cosmos DB account, and also multiple graphs within a database. So what's this Gremlin creature doing? A lot of if you're looking at the different icons that we've got for the various Azure services, they tend to be very functional. We can see that we've got Azure Functions, we've got Cosmos DB, we've got various SQL databases for that. So the icons tend to be a pictorial representation of what the service does. In the open source community, for some reason they seem to want to use animals and creatures to be able to represent the various technologies. You may recognize quite a few of them there. And Gremlin, the guy on the bottom right, is the character that they've chosen for the Gremlin API. It's actually an open source API that's specifically for focusing on working with graph databases and the graph database model. So onto the scenario that I'm going to be demonstrating. I was watching Game of Thrones when it was on. I was kind of addicted to watching this all through the I think there was 8 series of it. And round about the end of Series 7, this competition launched in the Neo4j community. Now, Neo4j is a different graph model to the Gremlin API, and it offers different capabilities. But there's also a lot of similarities in these two models. And in this community competition, there's basically a contest where you could win prizes. And the idea was to be able to model the Game of Thrones world in a graph database using the Neo4j. And the screenshots are showing some of the graph representations of the Game of Thrones world. Showing how we can get some insight into how the various characters are connected, and also how characters are connected with various relationships like marriages, parental relationships, siblings, and also being connected through various houses and religions and cultures and so on. It's a very rich, complex world that we've got in the Game of Thrones. So what I was thinking of doing was actually implementing this using Cosmos DB and also using the Gremlin API. I'd seen many people who've been doing this using Neo4j. So what I decided to do was to do this using Cosmos DB. I hadn't seen anybody else doing that, so I don't know if I was the first person to do that, but it was certainly fun to explore that. So traditionally, working with databases, you may be familiar with relational databases. Things like SQL Server and Oracle provide these various tables and schema definitions and relationships. And you spend a lot of time, building the tables, designing the tables, thinking about, the fourth normal form and all of this stuff, and designing all of the relationships within those databases. With Cosmos DB, we think about non-relational databases, both in the document and the column family, and also in graph. We're not really focusing on these kind of rigid schema with the relationships between the various entities in the databases. So the idea of using a relational database is when we're going to be querying that database, we end up doing lots of joins if we're interested in selecting things, and we're basically leveraging these relationships in the database. So here I'm using the AdventureWorks sample database in SQL Server, and I'm getting the sales per region, the sales categories per region. So what I've got to do is I've got to select from the country region table, and select from the addresses table, and then join onto the sales order, join onto the sales order detail, and then also join onto the product and the product category. And as we start doing these joins, the queries do tend to be a bit inefficient, and so you do tend to hit scalability problems when you're working with a relational database model. That's showing the execution graph for that type of query that we can run on that model. So if we're thinking about taking the Game of Thrones world, and we've only got relational databases as our data model, then we're going to think about, well, let's generate a table for all of the people. We'll generate a table for all of the houses. Then we can start to model and basically place in these various characters. So Tyrion Lannister basically serves House Lannister. Varys also serves House Lannister. And we can basically build this model by using a many-to-many relationship and creating a table to basically represent those relations. However, Varys also serves Tyrion Lannister. This has just broken our relationship model because we don't have the structure within our database schema to be able to model that relationship. However, if we're using a graph database, we're going to be defining the entities like the houses and the characters as vertices within the graph database. And then the relationships are going to be defined using edges. So there, Tyrion Lannister can serve House Lannister, Varys can serve House Lannister, but there's nothing to prevent Varys from serving Tyrion. We can just generate that relationship or that edge and link those two entities together. So this gives us a very, very flexible model that's going to be very useful for being able to work with more complex relationships. I think a good example of the graph database is something like LinkedIn. You've got a LinkedIn profile, and you work for a certain company, you've got various co-workers, you went to a certain university, you live in a certain town, and you've got connections with certain co-workers, and you're a member of certain groups. And all of these relationships can be very easily modeled using a graph database, and also, more importantly, very efficiently modeled. So in comes Gremlin, the graph traversal language that we're going to be using in this demo for actually modeling this. So when we're actually doing what we would call a query on a graph database, we don't call them queries, we actually call them traversals. And Gremlin is a graph traversal language that allows us to be able to run these traversals on the graphs and be able to extract information from that. So we have a sequence of steps, and they can be potentially nested. And each step is going to perform an atomic operation on the data stream. So we can do things like mapping, filtering, and then various side effect things like sorting and counting and stuff. And we'll see all of these as I run through the example queries in the database. Now, I really don't like the term NoSQL because NoSQL is really describing that a system does not support the SQL programming language. I prefer using non-relational. So think about the document database in Cosmos DB. It's a non-relational database, but we do use SQL to be able to query that. However, I do think NoSQL is appropriate when we're using the Gremlin API. Because if we're doing using a relational model, we're going to be building up a query like this to be able to select from the various relationships if we're interested in loyalties on various people. Whereas in Gremlin, we do something like this. We do g.v Tyrion.out serves. And what I'm looking for is basically anybody who is serving Tyrion, and I'm basically able to build up that relationship in a very, very simple and very efficient query. So, first step was to gather the data for the Game of Thrones. It is incredibly complex. There's a lot of stuff going on in the TV series. So what I did was I used the Game of Thrones wiki site, and here we can see the information on the character of Jon Snow. We get all of this information provided in the wiki for all of the characters within Game of Thrones. So what I did was I used a technique called screen scraping to be able to take this information and to be able to get the information into a machine digestible format. And I chose JSON to represent the information. So the screen scraper will basically go in and it would extract the name, the father and the mother of the character, the siblings, the religion, and so on. And you can see it's basically extracted out the various data like the titles and allegiances and so on. And what we can then use this JSON to actually drive the data input. So it's kind of a two-stage process. The first stage is to extract all the information from the wiki and get it into one really, really big JSON file. And then we're going to pass that JSON file and run the queries to be able to get the information into Cosmos DB. So this is what the query language will look like when I'm using the Gremlin API to get the information into Cosmos DB. I'm adding a vertex, which is a character, which is Jon Snow. I'm then adding the relations to Jon Snow. So what I'm doing is basically selecting that Rhaegar Targaryen is father of Jon Snow. Lyanna Stark is mother of Jon Snow. This is from Series 7, by the way, so I think that's what we knew in Series 7. No spoilers, but I think that data did change a bit in Series 8. We can also drop on the allegiances. Jon Snow serves House Stark and House Targaryen and the Night's Watch. Jon Snow is from the Northman, and Jon Snow worships the old gods of the forest. So we can basically add on all of these various relationships and characters to be able to build up the whole graph of the Game of Thrones world. And this is kind of showing the different allegiances and connections that we will have on Jon Snow. So building up the actual Graph of Thrones model, I'm going to jump out into the Azure portal now. And I do have a pre-prepared database, but I'm going to create a new one anyway, just to show you how this process works. So I have my Cosmos DB account, and this has been created using the Gremlin API. And if I go into the Data Explorer, I've basically created a DB of Thrones test, which I have populated with a test data. But I'm going to generate another database just to show you how that process works. So I drop on a new graph. I'm going to create a new database called DB of Thrones. I'm going to select a new graph, which is called Graph of Thrones. And for the partition key, I'm going to use key. Which is going to be coming from the actual data. I'm going to leave the auto scaling on with a max of 4,000 RUs. The reason I do this is the data input process is fairly heavy. We're going to be running at lots of transactions. So I want the Cosmos DB database to actually scale out, scale up, and be able to actually meet any capacity that I want to throw at it. So that should be fine for that, and I should be able to create that graph. And whilst that's churning away, I'm going to jump into Visual Studio. I'm going to need to, I think I've got these settings set. I think I've spelt this correctly, DB of Thrones and Graph of Thrones. And I can just show you the code that's going to pass the data. So, Game of Thrones edited.json. This basically has some cleanup work. When I got the raw data out, which is this Game of Thrones.json, there were some things that I needed to actually change and modify. So there's usually a bit of a cleanup when you've got to do a data import here. But here we can see the actual JSON file for all of the characters. And if I scroll down to the bottom, you can see there's about 9,500 lines of data here, listing all of the characters that I could extract out of the actual wiki site and all of the relationships and so on. And what the console application is going to do is to basically pass through that JSON file and build up the actual queries that we're going to insert into the Cosmos DB database. So I'm just going to drop back to the portal, and you can see hopefully that this has been created. We've got DB of Thrones, and within the Graph of Thrones, we've got an empty graph. If I execute this query, you can see that no results are coming back from that query. The graph is empty. So hopefully I should be able to run my console application and get that data import running into the database. So I'm just going to run the console app. And here we can see that we're pushing in all of the character data, and there's going to be quite a lot of characters. We'll see some information statistics later on sort of how large the actual database is, but there goes all of the actual character information. A couple of exceptions there. I'm not sure why those were occurring. I maybe need to go in and troubleshoot those. Now we're pushing in the allegiances, we're pushing in the cultures, the religions, and now we're dropping in all of the actual relations. And there's going to be a lot of these edges that we're going to be adding, linking the various characters to the other characters within the Game of Thrones world. Okay, so whilst that's churning away, I'm just going to drop back to the portal, and I should be able to start running a few basic queries on the actual Game of Thrones. If I actually run g.v now, we should see that we've got some information here. I'm just going to minimize these windows here, so we've got a bit more space to actually view the actual graph here. What we can see when we're querying this is we're getting the main character of Eddard Stark, and we're also getting the relationships to other characters, and we're able to explore this model and bringing out the other relationships from these. I might just zoom out of the portal a bit, see if I can get this in something that's a bit easier to digest. So as we're basically navigating this, we have this model now that we can actually use to explore the Game of Thrones world. The input is now complete. You can see there that all of the actual data has been pushed in there. So we can now start to explore this graph model. So querying this is bringing back all of the characters. I can select any character within the Game of Thrones world. That character is going to be displayed, and then we can go on to House Mormont. We can expand House Mormont, and we can see the different characters that also serve House Mormont, along with John Mormont, who I've selected. If I expand the properties again, we can see all of the people who are basically serving that particular house. Now, typically, when you're building an application, you're not going to be using this graphical view to explore the Game of Thrones world. So what we're going to be doing is looking at the actual queries that we're going to be running in this window here. So I'm going to look at some of the actual data. G.v is going to select all of the vertices within the graph. I can also do a g.v.count, which is going to tell me how many vertices we've got. So there's 872 vertices. And then if we want to look at the edges, we can do g.e.count. And we can see that there's 2,095 connections between each. What I can also do is on the vertices, if I go to g.v, I can look at the label and then do a group count on the label and run that query. And what this is doing is telling us that we've got 660 characters, 164 allegiances, 38 cultures, and 10 religions. If we look at the edges and do a group count on them, we can see the numbers of the different edges. So there is 119 marriages in there. We've got 193 is father of, 925 serfs. So you can basically see all of these differences that we've got, all the ways that these characters are connected. What we can also do is do queries to select what are the relationships between these various characters. So if I go to g.v, I'm actually going to paste this in. If I just query for Eddard Stark, this is basically bringing up the JSON which is coming back, which is describing Eddard Stark. So that's querying that particular vertex, the vertex with that particular name. And if I want to find out who his children are, I can look at the outbound relationship from Eddard Stark, and I can ask for is father of. So what this is bringing back is Eddard Stark's children. And you can see we've got Sansa, Arya, Robb, Bran, Rickon, and Brandon coming back here. If I change this relationship from an out relationship to an in relationship, then I'm going to be looking for Eddard Stark's father. which is coming back as Rickard Stark. So I can now take Rickard Stark, drop Rickard Stark in there, change this back to an out, and then we've got Rickard Stark's children. And you can also combine these queries together. So if I want Rickard Stark's grandchildren, I can just copy paste that query there. And what now is looking for Rickard Stark out is father of, and then for all of those nodes, we're looking for out is father of as well. So you can come back here and you can see the list of grandchildren from Rickard Stark. So it allows us to be able to explore all of these various relationships within the Game of Thrones world. So if I'm going to go back to Eddard Stark, and what I'm going to do is to look at who Eddard Stark serves. So I'm going to basically go out and then go serves, run that query there. And you can see that Eddard Stark serves House Stark and House Baratheon of King's Landing. Now what we can do, because this query is returning House Stark and House Baratheon of King's Landing, what I can do is basically drop on. I keep calling these queries, they're actually traversals. This traversal is bringing back those two results. If I now go in and drop this onto the end of the traversal, this is going to return, this bit is going to return these two entities. And then what I'm looking at is, well, who also serves these two entities? So from these two entities, who has an inbound relationship to serving those entities? So if I run that query, this is showing us everybody who serves alongside Eddard Stark. So is connected to Eddard Stark through, the two entities. They basically serve the same entities there. So what we're doing now is kind of exploring the relationships within Game of Thrones to find out, do these characters have quite a lot in common with them? Do they serve alongside each other? There's some more complex things. What I'm going to do here is just drop in this traversal here, and this one is going to look for the most influential organizations. So I'm looking for G.V. I'm selecting all of the vertices, and they have an outbound relationship which is serves, and then I'm doing a group count and ordering by the value descending. So what this is going to show us is, which institutions within the Game of Thrones world have the most people serving them. So House Stark comes up at the top with 86, and then we've got House Targaryen with 84. And if we scroll down, we'll see, the lesser houses within the Game of Thrones world, and you get right down to the bottom, and there's some of them where there's only one character that's actually House Humble, only has one character that has an allegiance to House Humble. So Humble by name and by nature. Okay, so my kind of idea by this, the way that these graph databases are used within things like LinkedIn, is to be able to do things like friend recommendations. So I thought it might be fun to see if we can do a friend recommendation within the Game of Thrones. So I'll round off my demo just by dropping in this traversal there. And what I'm doing is taking Jon Arryn. I'm looking at both the inbound and the outbound relationships, but I'm limiting the results to only characters. Only characters are going to be present in friend recommendations. And then I'm doing the sorting to basically sort all of the characters in the Game of Thrones world that have the most in common with Jon Arryn. Jon Arryn comes out top. He has the most connections with himself, but then we've got Peter Baelish coming out with 10 shared connections, Robin Arryn and Lisa Arryn here. So this is kind of like a friend's recommendation from Game of Thrones. Peter Baelish is coming out top. I would be scared if anything was recommending Peter Baelish as a best friend. But let's drop him in anyway and see what comes out. And it's saying Jon Arryn is got 10 connections. Those are 10 shared connections. And we can go down and find these other characters. We can take Cersei Lannister if I can find her, and we can drop her in and see what her friend recommendations will be. And then we've got Jaime Lannister coming out as the top friend recommendation there. So that was quite accurate if you watch the Game of Thrones series. So takeaways on this. If you've been working with traditional models such as regular relational databases, or maybe working with the document model in Cosmos DB, the graph model is very different. I try to think to that adage, if your only tool is a hammer, then every problem is a nail. We do now have these graph capabilities available in Cosmos DB, and if the challenge that you're trying to solve seems to be very graph related, it could be suited to working with this graph model. definitely worth exploring and working with this. This is the first thing that I built on the Gremlin API in Cosmos DB. It was a bit of a challenge for me to get my head around how the graph databases worked, but it wasn't too difficult to get the actual model working. Most of the challenges were related to the data import. And we are using the graph model at my company in a couple of customer solutions. So I definitely recommend spin up an instance of Cosmos DB, run through some tutorials and experiment with the graph model and see how it works for you. So thanks for listening to my session. My name is Alan Smith. I work for Active Solution, and I do have some content up on YouTube if you want to go and check that out. Enjoy the rest of the conference.